Alright, should be just about done. Warm up number 44 reads, compute the measure central tendency and sketch a box plot. So here it goes again. Sending order 2, 5, 7, 9, and 12. Measure central tendency, by now we know what they are. I'm going to start with mu. And that's my mean. So 12 plus 12, 24, plus 2, 26, plus 9, that's 35. Divided by 5, that's 7. And we got that? Let's go. From there, we need the median, or Q2. And it's still 7. And mode? None. All right. So, Q2, we need Q1, which is 3.5. Hands, you got 3.5? All right. And we need Q3, which is 10. You like that one, right? 10.5. And did you got that? All right. So we got 3.5, 7, 10.5. Max 12. Minimum 2. All right. So send that in, please. Copy the agenda. Warm up number 44, measures of variation. Tonight's home play, page 143, number 6, using the shortcut formula. You're like, what? Oh, yeah. Last week and throughout, we've been using our formulas. We introduced formally the formulas last week, bless you. But we've been doing the process all throughout the school year. Today we're going to transfer that to the shortcut formula. You're like, you should have given us that, Mr. Q, first. No. Because then you're just going to use that all the time, right? Not that you guys would, but you know what I'm saying. So, like I said, today we're transferring that. Number 6, you guys already did for home play last week, but you did that the long way. Okay, it had 3 different data sets. Thank you, Mr. Q. All right. Copy the code for your home plate. 9JZQX. 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 All right. Once again, last weekend it was Act Like Tomatoes. Pretty good, yeah? And tonight is this one. You have the code. So, you got a Cornell note ready, please? And once again, our objective for today, I can summarize data and compute the measures of variation. I can summarize data and compute the measures of variation. I can summarize data and compute the measures of variation. So once again, turn to your neighbor and let them know what the measures of variation are. What 3 measures of variation have we been working with? All right, good. Good communication. All right, so without looking at your notes, write me a definition for measures of variation in your own words. Let's see, by now you should know what they are. Not which ones, I'm saying a definition in your own words. What would be measures of variation? Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Here's one from one of your colleagues. And they wrote Variation of measurements that are spread out. I'll take that. Pretty close, yes? Yes, Mr. Q. All right. So, we got that. You have the notes on this. All right, once again, tell your neighbor what data measures have we covered and which one is the last one we're headed towards. Which ones have we covered and where are we headed towards? Without looking at your notes. All right, write them in there, please, on your screen. Write them on your screen. Bye. Oh. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, thank you. Oh, sorry, wrong screen. All right. So help me out with this one. Let's see. I'm going to pick someone randomly. Let's do Martin. What's the first set of measures? Can you refresher? All right. You just did the warm-up on them. Central tendency. And they are the mean, median, and mode. All right. So far so good, yes? Next, pass to someone. Julius, what's the next set? Yes, variation. And they are the range, variance, which is sigma squared, and standard deviation, which is sigma. Yes. And the last one that we're headed towards, pass someone. Martin. Jacob. Wow, position, my goodness. Measures of position, that's where we're headed towards. So, last week we ended up with 2, 4, 6, 7, 8, 9, 10, 11 formulas. Is that correct? So, the last two formulas were the same as standard deviation, the variance and standard deviation, but for population. But look at my formulas of today. Go back to your end of the notebook and see if those two formulas match mine. So you never, what's the only thing that changed? What's the only thing that changed? The denominator where it says n minus 1. So for samples, you're going to write n minus 1. And you're probably thinking like, Mr. Q, why don't we just leave it as n by itself, but low cap, and that's it? Well, since sometimes we end up with smaller data, let's say like 4 to 10, sometimes it creates an error on the computation. So to compensate for that error, they need this minus 1 on the n on the denominator. So make sure you write that there, please. All right? So, once again, sample formula, same thing as the population one, except for the n is what? N minus 1. All right? So with that said, let's go to our first problem, example Q. Copy that data on your paper, please. Example Q. Example Q. And it reads, the number of public teacher strikes in Pennsylvania for a random sample of school year is shown. Find the sample variance and the sample standard deviation. sample variance, and sample standard deviation. So, we got 9, 10, 14, 7, 8, and 3. So let's do the process completely just to make sure we got it. Once again, don't copy the problem, just copy the data. And then we're going to start our first column with what? X. First column with X. All right, ascending order, we got 3, 7, 8, 9, 10, 14. We good? Yeah? So, tell your neighbor what to do first with all that data. What do we do first with all that data? Looks like AJ's got it. Very good, AJ. What do we do first? Mark. Yeah, that's the end product, but what is the first thing we do, aside from ascending order? My goodness. Noah. Add it all together and divide by, how many of them? 6. So we find the mean. However, look up, please. From now on, you got to be careful with the word problems that you are given because look, what does it say here? Sample. So we're not going to use the regular formula by using mu. We're using what for the mean? We're using x bar. X bar. All right? So add that up. Divide by 6. Find me the mean, please. Is it 51 over 6? Yeah? Therefore, mean. Bree, what'd you get? 8.5. Thank you. Next, what do we label the next column? The data minus what? Mean, x bar. That is correct. So we got 3 minus 8.5. 7 minus 8.5, 8 minus 8.5, 9 minus 9.5, 10 minus 9.5, and 14 minus 9.5. All right, and that gives us negative 5.5. What happened? Oh, 9.5. My bad. I did that to see if you guys were paying attention. Eight 8.5, and 8.5. All right, so we got negative 1.5, negative 0.5, 0.5, 1.5, and 5.5. Is that correct? Yeah. So what do we label this column? We label this because what is the next step? What would be our next step, everyone? What do we do to each of these numbers? What do we do? Jessica, what do we do to all these numbers? Square them. So this column is x minus x bar squared. So square this, square that, square that, square that, square that, square that. All right? So, this gives us negative 5.5 squared. Calculators calculate. Let's see, JJ, what'd you get? $30.25. How about 1.5 squared? Is that 2.25? 2.25. Negative 0.5 squared is 0.25. 0.25. 2.25. And 30.25. All right. What do we do next? Find the mean again. However, this is no longer called the mean. What is it called? Tell your neighbor. Second mean is no longer a mean. What is it called? Share with your neighbor. Looks like Alyssa's got it. Very good, Alyssa. What is it called, Adisai? That's it too. Alyssa. Variance, but for what, everyone? Variance for what? Sample. So what is our formula? It's S squared. Is that correct? So what do? We do x minus x bar squared over what, people, for the sample? We just said it right now. N minus 1. That is correct. So, we need to find this. So, 30.25 plus 2.25 plus 0.25 plus 0.25 plus 2.25 plus 30.25. Add them up, please. Should be 6550, is that correct? Yes? And then divided by 1, 2, 3, 4, 5, 6. But what is 6 minus 1? That is what? 5. So my variance for the sample is let's see, 0, 1, 1. Oh, my bad. 13. 13.10, is that correct? All right. And what is left, everyone? What's our last step? We need what? Standard deviation for the sample, which means we take all this and do square root. So, square root of 13.10. What'd you get, Anthony E? Square root of 13.10. What is it? 3.61 to the round. What's the next number after 1? No, I'm saying on the calculator. 9, so let's round to 2. 3.62. All right. Send me your notes, please. I want to see what you did. Make sure you have that. All right? So, by now we're experts at this. Is that correct? All right? So today, instead of doing all of that, I'm going to give you 2 formulas that are going to be shortcuts. They go a little bit faster. So for the home play for tonight, you're going to use the next formulas that you see. So look up. Here are the 2 new formulas that are shortcut formulas. Write that down on your paper. Don't write it in the back yet. Write it here and right after that problem, because we're going to use them right now. Shortcut formulas. So for the variance sample, we've got that formula, which is n times the sum of x squared minus the sum of x, take that to the second power, over n times n minus 1. And of course, standard deviation is all that, taking it to the square root. Okay? All right? You just zoom in and can barely see the work. Ah. All right, so we're going to use these two formulas next. Here we go. So by now we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Man, this sounds like a pop tart cake to me. Ooh. Like, what is the sample variance, right? How about that? Anyways, here we go. Write example super Q. Copy that data exactly how it reads. 9, 10, 14, 7, 8, and 3. And this time we're going to use the shortcut formula to find the variance and standard deviation. Okay? And notice again, I left it with a letter S over here on the sides, S squared and S, because this is a what? A sample. Okay? So first things first, let's look at our formula. Let me zoom in. To find the variance, they're asking us for n, which is the number of data. Is that correct? Do we know how many numbers we have? Yes. All right. What else do we need? The sum of x squared, or the data squared, and the sum of x. So, to distinguish one from the other, look up. I'm going to label the first one, this one in red, or pink, and the second one, this one, in green. So like that we know which one is which, okay? So once again, pink or red, green. Let me zoom out. So the first things first, I need the sum of, I'm going to start with the green one. Here we go. So the green one is the sum of x. So I'm going to write it over here. Follow my lead, please. Write sigma x, or the sum of x. So, how many data do we have? 6 of them, so we need the sum of all these numbers. So, find me the sum again. $51. Thank you. JJ in the house. All right. So, once again, tell your neighbor how we found sigma x. How did we find sigma x? Just by adding the numbers. Okay. So now I'm moving to the other one. And I'm going to label that one in pink or red. And that one is the sum of x squared. So again, sigma x to the second power. So what does that mean, Mr. Q? That means, look up, that I need to take each of these x's and do that to each what? To the second power. Is that correct? So what is 9 squared? 81. What is 10 squared? 100. What is 14 squared? 196. What is 7 squared? 49. What is 8 squared? 64. And what is 3 squared? 9. And now we just need to find the sum of all those. Find me the sum, please. All right, looks like Rianne's already done. Very good, Rianne. All right, Rianne. 81 plus 100 plus 196 plus 49 plus 64 plus 9 is... 500 what? 400? 499? All right, 499. Hands, you got 499? All right. So now we have almost all our information. We just need the value for n. Tell your neighbor what we're going to write for n. What do we write for n? Martin, what do we write for n? What do we write for n? 6. That is correct. So let's follow the formula. Here we go. Variance of sample. Then we got n. I'm going to write it first so you guys can see it. The sum of x squared minus the sum of x. And I'm going to take that to the second power. And then I got n times n minus 1. So, variance, we got blank minus blank squared blank times parentheses blank minus 1. All right. So n is 6. Here we go. 6, 6, 6. What is the sum of x squared in red? That was what? 499. Yes? And I got that from over here. What is the next thing? The sum of x, which is this. What is the sum of x? The sum of x is 51. All right. Let me simplify this. All right. So, calculators, calculate. What is 6 times 499? 2,994. 2,994. What is 51 squared? What is it? 2,600? 2,601. And what is 6 times 6 minus 1, which is 5? What is 6 times 5? Bless you. 30. So, sample variance, 2994 minus 2600, that's 393 divided by 30. 393 divided by 30 approximately is 13 what? 0.1. All right. So that's the variance. What do we need to do at the end to find our standard deviation? Tell your neighbor. What do we do at the end to find our standard deviation? Yeah, square root. Take the square root of that. And that should give me, watch, I'm gonna use my Jedi Master brain power. About 3.62 approximately. Hands if you got something like that. All right. Now check this out. On the previous one, what did we get for the variance? Look at the previous problem. What did you get for the variance? 13.1. How about for standard deviation? Approximately 3.62. So, send me your notes for that one. So, we have the previous process, which is the long way. Yes? Look up. Long way. And we have the shortcut formula. All right, so how comfortable are you with the shortcut formula from 1 to 5? Yeah, 5. And if you notice, pretty much everything's just calculator and computation, yes? Pretty straightforward? Yes, Mr. Q. All right, good, good, good. All right, so do me a favor, go to the end of your notebook and copy the last two formulas onto there, please. These two, add them to your formula menu. Those are the shortcut formulas. All right? And let me send all the formulas to your screen just in case you are missing any, so you can double check your formulas. Now we have 2, 4, 6, 7, 8, 9, 10, 11, 12, 13. Let's go. All right? So, there they are. And for those of you following along on YouTube, this is the practice for tonight. There's 3 sets of data. You need to find the variance and standard deviation using the shortcut formulas. All right, I'm going to stop the video right here. And once again, put in some work. And I'll see you guys next time. Peace.